We now start talking about curvature. Let's say C is a curve given by the vector function r of t, which is equal to x of t, comma, y of t, comma, z of t. So we are taking a curve in the 3 space. However, our discussion equally applies to a curve in the 2 space or any other space. We're going to assume that our curve is a smooth curve. What that means is that the derivative of r is continuous, and r prime of t is never equal to the 0 vector. Now, if you think of c as the path of a moving object, then and r of t as the position vector of that object, then r prime of t is the velocity. So when we say we have a smooth path, it means that the velocity is continuous and the velocity is never equal to the 0 vector. Now, the second condition here ensures that the second condition ensures that the path doesn't have a sharp corner. Okay, so what is curvature? Well, curvature is a measure, and it's a measure of how quickly the path changes direction at a point. So if you look at the point here and the point here, notice that the direction at this point changes more quickly than it does at this point. So the curvature at this point should be higher than the curvature at this point. So what I want you to do is take a few minutes and think about how you can come up with such a measure. That is, again, you are trying to measure how quickly the path changes direction at a point. Now, you can think of this as a racetrack, and then you are looking at how direction changes along the racetrack. So go ahead and think about how you can come up with such a measure, and in the next video we will try to come up with one.